Alrighty, let's see if this works. I know my stream was scheduled for 8:30, but I don't have anyone that really subscribes to my channel. So I think I have more than enough approval at that point to go ahead and start live streaming when I can. I just need to double check the stream really quick, make sure it is running well. Um Yep, looks like it's running well. So, looks good. We're there. For those of you that don't know, well, if you haven't watched the channel introduction, my name is John. I am a software engineer that has a commercial software engineer that is moving into game development and have been for the last few months as a as kind of a side project and just broadening my horizons and as well as honestly a slight a slight career midlife crisis with AI. Uh, and I feel like game development is one of those kind of the last bastions of just general engineering that doesn't have what's the word I'm looking for, that's really frowned upon in this context. So finding an area in which I don't feel pressured to use AI, where I don't, have to run agents and work through all that means a lot to me, and helps kind of just build my engineering. So enough about me, enough about what I'm doing here. Let's talk a little bit about this project and what I hope to accomplish. So some of the games that I am most inspired by are Dwarf Fortress and Caves of Cud. They the sheer amount of work and love and passion that has been pushed into those games and the technical achievement, the engineering behind those, just stands for me as a test of time. And yeah, they're not they're not like visually, uh, aesthetically. I wouldn't say they're not aesthetically pleasing, but they aren't mainstream graphics. Obviously, they are very much roguelite ASCII graphics. I mean, that's how Dwarf Fortress and Caves of Cut, I think, both started there. So finding finding a genre of games that I enjoy, um, has been what I've been doing the last few months. I have tried a bunch of different genres, 2Ds, platformers, some 3D cozy placement games, trying to find a genre that I was very interested in. And I've landed on simulation. The problem with simulation games and the problem with simulation games in modern game engines, in my opinion, and keep in mind this is my opinion as a new game dev and as just a standard engineer, is that the object oriented nature of most game engines, Unreal, Unity, Godot, granted they do have non object oriented things, but anyways, their focus on object orientation, node hierarchies, and how their engines are put together don't lend themselves well to using the game engine to model simulated environments with large amounts of entities. And we're talking thousands and thousands of entities interacting with each other every tick of the game world. So not only do those engines not necessarily perform well with large simulation heavy games, uh, but I did not enjoy writing scripting in either in those games. So I tried GD script. I've primarily worked with Godot, some Unity. I've done the C sharp on Unity and Godot both. I prefer C sharp if I have to use a scripting language, but C sharp and .NET is so heavily object oriented. Public abstract classes and templates and just all these wonderfully what I feel bureaucratic things in the language that it was hard to enjoy programming in it. And I have to find enough motivation to continue onwards, and push through. I have to do something that I enjoy, and if I'm not doing something that I, at least at a base level, enjoy, then I'm not gonna be able to push through those hard times as a game engineer. So that's why I I started playing around with the Bevy engine. For those of you that aren't aware, and I'm gonna go ahead and switch my view here into kind of my web browser here and go to the Bevy engine. So let's go to web. So for those of you that aren't aware, Bevy is a game engine that's built in Rust, and I'm not gonna go too much into in this podcast as to like Rust and let's rewrite it all in Rust and all the memes. But I have used Rust pretty extensively for a couple of positions. I've used a lot of different languages. Rust, I do enjoy. I feel there's a lot of positive aspects of it. But what's more important than the fact that it's in Rust is that this is a data-driven game engine, and it's particularly using an entity component system versus an object-oriented game hierarchy. I'm not going to attempt to explain in detail the differences between ECS, and that's what we'll refer to as entity component system from now on because it's just a mouthful, and object-oriented game hierarchies. But what I can tell you is that in an ECS system, and doing it in a low level language such as Rust, you are able to manage a lot more entities. In this case, and they'd be nodes in Godot, but you're able to manage a lot more of these entities in a single tick or part of the engine than you would otherwise. And when dealing with simulation, when you have uh, let's say, just hundreds of or thousands of different entities that have their own components and systems and behaviors interacting with each other in near real time, you need a very fast system for dealing with those things. So Bevy really called out to me as a okay, it's an entity component system. It makes more sense for simulation. I don't have to um, rebuild kind of a simulation engine from scratch, like a lot of these other individuals, like Caves of Cud and Dwarf Fortress. I believe are both C++ custom engines. I think Caves of Cud is either in Unity or Godot as a front end, and we'll talk more about that today, as because that's honestly how I'm kind of structuring my project as well. But I started going down the road of using Bevy after a couple of months of being pretty exclusively in Godot. Um, where I started to struggle with Bevy is that it's definitely not a the rendering engines for it are great. They work, but I don't think it's production ready yet, for, like, shipping real games. It has a lot to be desired as to, like, user interface. There's no real user interface, except for what other people have built. They do have a lot of different UI frameworks. They've got some hallmarks of, like, other game editors such as Scenes, um, and, of course, you have all the low level aspects of Rust you have, that you have access to. But I was worried that one of my biggest targets for this, the Steam Deck, while it can compile and run in Linux fairly easily and run particularly on the Steam Deck very easily, things like handling audio, things like handling the Steam Deck's input or gyro, or doing any kind of Steamworks SDK integration, um, could prove more difficult. Now, granted, I'm probably gonna have to use the Rust bindings for that anyways, but it could prove more difficult. Also, any kind of collaboration would mean that anyone that's working on this project um, is going to have to be a programmer, honestly. to understand and be able to interact with these systems and to collaborate with myself on the game. And I have a couple of other people that are interested in and kind of working with me to collaborate on building this game. Um, so I was worried and a little disheartened that I wouldn't be able to use a tool that I felt was extremely powerful, that was the right tool to run the simulation, and um, be able to enjoy the tool that I was using, right? So, oh, why is this chat is not staying up? Okay. The answer to this is actually something that I started Googling and searching for based on a Case of Cud interview. And what they talked about was in order to do their more modern looking AI or UI, what they did is they basically took Unity and he ported this to Godot in a single weekend. If I can find that, I'll throw that in the show notes. Um, but they basically ran the simulation engine in a thread and message passing back and forth from the game engine from Unity or Godot into the simulation, and then read responses and read game state and kind of passed it back and forth. So it was this true separation of game logic and the presentation layer, like the UI, and the rendering from the actual simulation logic that was running in a different thread under C++ and just entirely different kind of set of engine. And so I started to think about like, hey, is there something like this for Godot, or is there something like this where I can hook into a Unity? I really didn't want to use Unity. I don't agree with their license practices or their what I feel are shady business practices. So I avoided Unity as best as most I can and stay with Godot. And so I was trying to find, is there something in Godot that allows me to have an entity component system? And there's a few out there. So if you just go, entity component uh, system Godot, the first thing that's going to pop up is probably this GCS or sorry, Gex. And Gex is being actively worked on. The only problem I found with Gex is that it's in Godot script. It's not in C sharp, and it was not something that I don't enjoy GD script, and I didn't really want to work back in C sharp. And it seemed more of like tacked on behavior than necessarily an engine that was built for this. I think it's very, very well written. I think it's got some very awesome setups and systems in there, and the interaction with Godot is probably pretty high. Um, but it wasn't quite what I was looking for. What I landed on, and it's something that I found just a couple of days ago, is something called Godot dash Bevy. And Godot dash Bevy, um, and I'll throw this in the show notes as best I can, is actually a fork of Bevy dash Godot. Um, and what this does is it bridges Godot and Bevy. It allows you to use Godot's UI rendering layer, all the powerful aspects of those scenes, but drive your actual game logic and game behavior with Bevy under the hood. So if I was going to if I was going to show you how that worked, what we would have is something along the lines of like in the background we would have Bevy. Yeah, this is there we go. We would have Bevy, and this would be running whatever game loop you'd have in here. So I have a good loop thing. I wish I had a better arrow for looping. We'll just use the loop antenna here, just because it's fun. So Bevy you're able to use for the whole entity component system, and you're able to. We're going to talk about the one-way sync for right now. You're able to interact with Godot the Godot engine, which is running everything. And the way this works is the Bevy, instead of being compiled as a Rust binary, as an executable, you compile it as a library and use a Godot native extension to bridge that gap. And then you can use the Godot bindings in Rust to interact with Godot. So the idea here is that you send information up to Godot, and this could be, this could be nodes, you could be generating nodes, whatever. Godot renders this information or any information that only Godot has. And we'll talk about how I plan on doing a like a tile map and the initial plan as we get there. But the idea here is that Bevy syncs forward to Godot. Godot renders. Godot is what captures player input and sends that back um, as I don't want that, as a message, and I want that. Oh my god, draw Dido. What happened, buddy? Uh, there we go. So it sends it back, or it can. This is a little, let's see, misleading because it's not Godot sending messages to Bevy. That's not really how it works. But what you can do is the Godot signals, the signal system in Godot, which is, you can think of it as kind of their event-based system. You can subscribe to those events in Bevy. There's also, if we look in the Godot Bevy book, which is their little interaction, they have right off the bat built you some bridged input. But again, this is still events based. So you can see here, we're not taking events. Anyways, back to the diagram to make that make sense. Godot will emit any interaction from the user, especially through the UI that you've built in Godot, through any input methods such as a gamepad. It will emit those as signals, or it'll do whatever logic it does in its UI and emit what needs to happen in the game engine, the game logic, as a signal that Bevy is then subscribed to. So for example, let's say we've rendered a scene, we've rendered a tile map on screen with a player, and you push the left on a D-pad on a controller. What happens is that Godot emits a signal saying, "Hey, somebody pressed left on the gamepad," right? And Bevy, with the Godot Bevy plugin, is allowed to listen to those signals, listen to that input, and act on it. So now Bevy says, "Oh, hey, in my game logic, the somebody has pressed the left on the D-pad, and according to Godot, they're in this context because that came through on the signal. So I need to take X action. I'm going to move the player in my copy of the game world here." And then what we propagate back up to Godot is, let's say that the player entity, I'm not going to do that. Let's say the player entity has changed its position in the tile map. What'll happen is, okay, hey, the player, no, the player entity, which is now synced to a node in Godot, which, let's say it's a 2D sprite or something along those lines, has changed its position in the game world. Well, this synchronization step takes what's the source of truth, which is Bevy, represents it accurately in Godot, and the next rendering pass, it renders everything correctly. And we just go through this loop. We emit signals, Bevy listens, makes changes in the game world, sends that up to Godot, Godot renders, accepts user input, and we just go over in this circle. Why do this? Don't do this unless you have a reason to use Bevy. If you do not have a reason to use Bevy, just use Godot. Stick with Godot, or Unity. But we're talking specifically Godot. But stick with your game engine. If you do not have a reason to make this bridge, stick with Godot. I have a reason to do this because running a simulation in Godot's engine in C sharp is going to be just a massive pain. And I think it's going to cause nothing but heartache. And I'm not going to enjoy making the code in simulation. So instead, I'm using Bevy because it makes the most sense for me. So again, this is really cool. This is shout out to the people running this and doing the work here. But don't do this unless you have a reason to use Bevy. It's just not worth it otherwise. Excuse me. So with this out of the way, let's talk a little bit about project setup. I will put some of this information in the show notes as long as I remember. But let's go into the Godot game editor really quick. As soon as it launches, I think we just crashed it. Of course, it crashed because why not? And I typically don't have many issues with Godot. I love Godot. It's just it's fantastic. I really really enjoy Godot. So okay, let's go to Godot. Why is it? One sec. Godot. There we go. Okay. Oh nope, that's not what I wanted. That's the code. Let's go to actually to Godot. And I apologize if this is not easy to read yet. I'm working on figuring out what makes sense as a streamer. If I stream, if I do this longer, or if I just record videos, I don't know. Um, but this is a fairly standard setup for what I like to do in Godot. None of these folders really come standard. I think you typically start with like an SVG icon and like a project configuration. That's it. Um, what's been added here is the Bevy Godot, or sorry, Godot Bevy extension, which is a collection of editor scenes that manipulate the editor, the plugin itself, um, for interacting with a Rust project. And the way that looks is pretty easy. I don't know if you can see this. No, you're not going to be able to see this. But if you go into the project tab and tools, there'll be a couple of new tools you can use. One of them says set up Godot Bevy project and then build Rust project. What the setup Godot Bevy project does is it creates a Rust folder inside your game and creates a Rust project for you. We're not gonna be using the scripting engine in here. It doesn't do well with Rust's LSP. But you can see that this is kind of how it's laid out. And then it will generate this, which is the most important portion of the bridge, which is the Rust Godot native extension. This is a Godot native extension that provides the what do you want to call it? The bridge between the Rust library that we created and the C++ engine that Godot uses under the hood. So this is the bridge, this Rust GD extension that gets auto-generated for your project, and it runs there. The really cool part about this, and we're going to see this in the debugger. Let me make a quick change, because I was playing around with it, so I'm just going to do that. Cargo build. When you play the engine, and you're not going to be able to see the output, I don't think. No, you're not going to be able to see the output, but this is just a blank screen. But you can see we're getting a hello from Bevy ECS. And that's basically just telling you, hey, under the hood, Bevy is running, it's outputting. And we're going to look at that code in just a second. But it's very seamless. You do have to build your Rust project when you make changes. You can set up a file watcher to do that rebuild for you, or some hot reload system. Building your project typically does not rebuild your Rust project. So if I hit build C sharp, it builds the .NET, but it will not rebuild. It will not rebuild the. Why is it not? Okay, it won't rebuild the Rust project underneath the hood. So that's something to keep in mind as you get through the system. So let's jump into the code now, and I'm gonna get here. Do do do. Oh, get into the code here. Let's make this a little bit bigger. Okay. If anyone does watch, let me know if that's not big enough. I guess. So this is the same folder for our Godot project. As you can see, we have the same folders that was in Godot, our assets, our add-ons. Here's the Rust GD extension. You can actually see it's basically just a configuration file and the libraries that get output that are available for it. Don't need to worry too much about that. This is the C# project itself. Um, because we're using Godot C#. That would be my suggestion for you. Um, Partially because if we ever had to, we could probably call into the Rust library from C# a lot easier than we can do from GD script, but not going to get into there right now. Let's look at the Rust project itself. The Rust project is very simple. It starts out as a very simple Rust project. You have source, through these in. We'll talk about AI in just a minute. Um, and then, your standard cargo. The cargo, if you're familiar with Rust, and I would hope you are, and if not, you're going to become familiar very quickly. Looks fairly similar to a standard Bevy project. The biggest difference is that you're not going to ship with the default Bevy features, especially if you're using Godot as a rendering engine. You don't want to ship with like their 2D renderer. You don't need a lot of their functionality, like their UI portions. So you can ship with a very low amount of a low amount of features, and that's honestly one of my favorite parts of Rust and these packages is being able to lock these things behind features. And the Bevy state is basically the global state machines, and a lot of the ECS framework. And then you can see we have the Godot bindings. We have Godot Bevy, which is obviously the Rust side of that extension, and then this is just some parts of that I've pulled over from a previous Bevy project, so we don't have to worry about that too much. Really don't need the empty workspace. These are just the optimizations that Bevy recommends for working with Rust. So if we go in there, we go into our lib file, which is basically the root of our library that gets compiled. You can see that it's really not terribly complex here, right? Um, it's not terribly complex. You have a macro here, not a macro, sorry, a derivative. Man, God, sorry, excuse me. Anyways, annotating your application with that allows this to basically allows the when this is compiled to build the right FFI bindings, foreign function interface bindings, so that the C++ side of Godot can communicate with this and vice versa. Um, but if you notice, like the rest of this is a very standard Bevy app setup. You have your app, you interact with your app by adding plugins or adding system, and you do need the Godot default plugin. You can get you can choose different aspects of it as you go, uh, but the rest of it is just very similar to how Godot works, or sorry, how Bevy works under the hood. It's the only thing that I see that's typically different is that instead of calling like main and initializing a new app, the Bevy under the hood, the Godot Bevy is feeding you an already initialized application that you can then chain into adding all your systems. And the Hello World system, as you can see, there's no Bevy annotation on it. Or sorry, there's no Godot annotation or anything on it. It's a very standard Hello World system. Um, we have the local instead of the application scope, and we have the time resource so that we can do a timer. And all it does is it prints to Godot, hello from the Bevy engine. And what Godot prints is, if we dive into that, I think you can see that. Yes, you can. Um, it just prints the Godot console. I don't know yet. I haven't tried any of the loggers to see whether or not they will, if the log will go out to the standard out as well. So we'll have to play with around with that later. The last thing I want to do on tonight's stream, I'm trying to keep my streaming time to 30 minutes to an hour at most, simply to make sure that I can spend time on this, instead of just talking about it and trying to educate. Keep in mind, again, I'm doing this not for revenue. I'm not doing this because I want to be a big YouTube streamer. I am doing this so that I have an outlet to talk about what I learn and share what I'm doing, and just um, my wife's not very technical, so talking to her about ECS systems and how Delta time works, that's just not going to fly. We have other better conversations than that. Anyways, so I'm going to make a new file really quickly, and we're just going to call this readme, uh, read me, and we're going to make a markdown file. And what I would love to do here is to present some of the uh, constraints that I'm going to be working under on this project. And the reason I do this, and I try to do this with every project I do, even if it doesn't make it into the repo, it's on a post-it note somewhere. It's written down for me to see constraints, and knowing the constraints you have makes a better system. And I have I have a blog post on that somewhere I can definitely share. So what we're going to start with is we're just going to start with constraints, and we're going to do a bulleted list here. The first constraint is that whatever we make must be Steam Deck native. And what I mean by Steam Deck native is that it compiles to Linux natively. So no having to use Proton or anything along those lines. Um, handles Steam input natively, and that the UI is designed for handheld. The game we're building, I think, will definitely lend itself to being in handheld more than it would be a mouse and keyboard, anyways. So keep that in mind. So that's one of my first and biggest constraints. This we are targeting the Steam Deck. We want to make sure it's native, that it runs well, that it feels good. Steam Deck and handhelds are a big market. The bonus of this is that if we target a handheld and we target a controller-based system, that we are going to have a much better time on, if we ever get to the point of getting on a console, we might have a little bit of an easier time having a game that's already designed to be played with controller and played on a console. Uh, it's not necessarily my end goal to produce something on the console. Right now, my end goal is to produce something, period. Next constraint. This one dives into how Bevy and Godot communicate with each other. But we must always use, we're going to put this in code ticks, transform, sync, one way. And I'm going to put just a link to that as soon as I can find it. Where's Bevy? Where's Bevy Godot? And what this means, I guess, is transform sync mode. What this means is that there are three different modes in which you can bridge the gap between Bevy and Godot. One is you handle every synchronization step and what you want to sync between the two engines yourself. One is one way, which is, if you refer back to the diagram that we were on just a little bit ago, has to do with that loop we showed you, the event loop, where Godot only talks to Bevy through events, and Bevy pushes all the data to Godot to render and have the interactions with. So one way means that we always go that direction and we follow that event loop. There is another method called two-way in which Godot can influence or basically synchronize back down to Bevy any nodes and stuff that it creates. The problem with that is we hit performance issues. We don't necessarily need it for our project. So that's a big constraint. We have to stay in that mode. The other constraints I had in mind are more about game design and the constraints that we have there. Um, whatever we build, I have what I have. Let's see, um, art assets are not the primary draw or source of fun, and I'll put that in parentheses, of this game. This one is kind of a cop out too, but it's more for myself to be like, you know what? Caves of Cud does well. Dwarf Fortress does well. Other simulation games do well with a very either low poly, 2D, 8-bit graphics, ASCII graphics. We can make a fun game without having to be, you know, something as gorgeous as Mina the Hollower or Hollow Knight or anything along those lines. Now, if I do find an artist that's willing to work on this, oh, fantastic. That'd be great. And we can make art assets. But I don't want that to feel like it's the primary source of fun and draw in the game. Um, the other constraints that I have for tech, I don't know yet, and I think that's okay, because we can continue to add to this document as we go. The other constraints that we have. I will say all Godot scripting must be must use C sharp, and we must use the Godot game engine. That's kind of the last constraint I have for here. What I also like to do in a README, um, while I'm working on the project so that I can keep track of it, is to set up milestones. And the way I like to do milestones is we're going to do first milestone. And the first milestone that we're going to work on is going to be I need to prove, not necessarily prove, but I need to get something on the screen as soon as possible that Bevy moves and controls. So I'm going to call this um, simulated player or simulated NPC movement and player movement from good from Bevy to Godot. Now, I like to break down what this is going to involve, and this is kind of the next big parts that we're going to start working on. This is going to involve a basic simulation structure built out in Bevy for our basic simulation loop, and the NPC component. And we're going to talk more about what this game even is as we go, but don't worry too much about it yet. This is going to involve creating a tiled level with physics. Oh, the other constraint that we have is that we are a top-down 2D, um, top-down 2D, I think that's it. So tiled level with physics, exported to both Bevy friendly and Godot friendly formats. Once we have that tiled level, we now need to build a translation layer between Bevy and Godot for synchronizing player and NPC locations. Okay, sprite locations on said tile map. And then we need to, what's the word I'm looking for? We need to have basic collision physics interactions um, rendered correctly in Godot. The physics is going to be handled by Bevy. We're probably going to use Rapier physics for this. But again, remember that event loop. The game logic and state is all handled by Bevy, and then events come flowing in from Godot and we re-render. So we have to handle any of the physics collisions in Bevy in this manner, because if we try to handle any physics in Godot, Bevy's not going to have any idea of what's going on, especially if they're sharing the same tile map. So this is my next milestone, and I'm not going to even think about other milestones yet. Simulated NPC movement and player movement from Bevy to Godot, all of this. That is the next big thing to be working on as we progress this. Now, I'm not going to live stream every aspect of this. More likely, I will be working on it and then live streaming an explanation of what's been worked on since the last time, showing how things work, because I'm not going to. I find live coding boring, typically. I would rather see close to a finished project and then go through each aspect and understand it and understand what happened than watch somebody live code. And I would hope you're the same way. And if not, maybe this is not the right channel. If you can deal with his sometimes uh, very harsh, not harsh, stringent opinions, you can always go watch Jonathan Blow program his game. Anyways, so this is what I'm going to be working on as my next milestone. These are my constraints again. Let's put this one. Simulation must run entirely in Bevy engine. So there we go. That's where I'm at. That is the constraints in the systems. I want to just say a quick thank you if you run across this video. I hate saying it. Please share and like and subscribe. Um, I don't, I care that my enthusiasm for this and what I learn is helpful to somebody else. I don't care about the number of subscribers, even if I only have 2 subscribers. If I can help those 2 subscribers become better engineers, be enthusiastic about game development, navigate the crazy engineering world that we live in, that's all I care about. So with 43 minutes in, I'm going to call that a stream. Thank you so much for joining me. Please feel free to share, give me some feedback, let me know what I can do right and wrong. This is literally my first time, probably my first time streaming in a very long time. So please be patient with me as things improve, and we'll go from there. Thank you so much.